Namaste everyone. Hope all of you are well. Today we are going to discuss Ionic Equilibrium next lecture because since it is coming in the equilibrium chapter, that's why this is the 8th lecture. Till yet we have completed 7 lecture of Ionic Equilibrium chapter, equilibrium chapter. Since this chapter has been divided into the two parts, chemical equilibrium and Ionic Equilibrium. Before Diwali we have studied about the chemical equilibrium, and after Diwali we are going to discuss about the ionic equilibrium. Now what I want to say you that in the previous video whatever the things we have discussed, especially about the ions, that was acid base and means acid base theory of Arrhenius acid base, in which we have studied about the chemical species which dissociate hydrogen ion in aqueous solution is called Arrhenius acid. The chemical species which dissociate hydroxide ion in aqueous solution is called Arrhenius base. We have given some examples. Similarly, we have gone through the Lorentz-Bronsted acid base theory, proton donor and proton acceptor, and then we have moved towards the Lewis acid base theory, in which we have informed about the electron pair donor and electron pair acceptor. Now in this video we are going to discuss especially about the ionizations constant of water and the ionic product. Means in this video especially we will discuss about the ions. Ions means you know very well, this is a water. If I talk about water, H2O, you know very well, if I talk about the equilibrium of water, water dissociates or water splits into H plus and OH minus ion, right? Now here according to the Arrhenius acid base theory, H plus, the chemical species which splits H plus in the aqueous solution, it becomes acid, and the chemical species which dissociate hydroxide ion in the chemical species, that is called Arrhenius base. You know very well, when H2O mix with this H plus, then it becomes hydronium ion. This is called hydronium ion, right? Correct? So here if I talk about Arrhenius acid, water is Arrhenius acid also and water is Arrhenius base also. But if I talk about Lorentz-Bronsted acid base theory, then yeah, it is acid but it's not a base. Yeah, it will be base in the case of when OH accepts H plus and becomes H2O. In that case you can say yeah, it is Lorentz-Bronsted base also. Now come directly to the point of electron pair donor and electron pair acceptor, because why this Lewis acid base theory has given this concept to understand that ions, if you turn any element into the ions, right, then only you will be able to understand, yeah, this ion can conduct electricity. Yeah. So if I talk about hard base or soft base or hard soft acid base theory, when you will go into the higher standard like BSc, MSc, that time you have to learn one theory that is called hard soft acid base theory, HSAB theory. In this we have to only understand till the conjugate acid, conjugate base, which elements dissociate hydrogen ion, where there is a replacement of hydroxide and hydrogen ion. So that are the things I have already discussed in the previous video. In this video especially I am going to discuss about the ionization constant of water and its ionic product. So some substances like water are unique in their ability to acting both as an acid and base, as I have already shown you on the board. In presence of an acid, hard acid, it accepts a proton and acts as a base, while in the presence of a base minus, it acts as an acid by donating a proton. In pure water, one water molecule donates proton and acts as an acid, and another water molecule accepts a proton and acts as a base. At the same time, the following equilibrium exhibits. Means as you can see here, this reaction can be also written as like this: H2O plus H2O gives H3O plus and OH minus, right? So here when already I have told you about when H plus and OH minus or OH minus absorbs H plus, it becomes H3O plus, you can see hydronium ion. And here OH minus will give again the next water molecules, it will become here H2O, H3O plus, again this will become H3O plus, and continuously this reaction will be going on. So if I talk about this acid base, so you can say here that H3O plus is a conjugate acid. What it is? H3O plus is a conjugate acid. But if you want to take a dissociation constant, right, What is the dissociation constant of this? The dissociation constant will be K is equal to H3O plus concentration, OH minus concentration and H2O concentration. So this will be dissociation constant for this ionization constant of water and its ionic product. Now, if I talk about the ionic product of water, right? What is the ionic product of water? If anyone will ask you, then you can directly say the concentration of water is omitted from the denominator, as a water is a pure liquid and its concentration remains constant. So water is and incorporated within the equilibrium constant to give a new constant. So that's why here you can write Kw as the ionic product of water. What is the ionic product of water? Can you tell me? The ionic product of water constant, here it will be H plus and OH minus, because water splits into this, right? So this is the ionic product constant of water. That's why I have written there Kw. Kw means here the water constant, right? So ionic product of water you have seen H plus and OH minus. Now the concentration of H plus has been found by experimentally. If I talk about H plus, really, it is 1 into 10 to the power minus 7 molarity at 298 Kelvin, and the dissociation of water produces equal number of H plus and OH minus ion. So the concentration of hydroxide ion will be also equal to 10 to the power minus 7. Means if I talk about H plus, the value of H plus and the value of OH minus is equal to 10 to the power minus 7 molarity. What is this? Can you tell me what is this? This is the concentration of hydrogen and hydroxyl ions value, which is at 298 Kelvin temperature. So if you want to calculate the ionic, means you can say that rate constant, similarly ionic constant product of water, Kw, then what you have to give, it's very easy. If you want to find this Kw value will be H3O plus and OH minus. So it will just be like 1.0 into 10 to the power minus 7 m whole twice. Rate constant of water value will be, so 1 into 1 will be 1, right? And 10 to the power minus 7 into 2 is 10 to the power minus 40 m. So this is the value of rate constant of water, right? So the density, if I talk about the density, now can you tell me that rate constant temperature will be dependent on the equilibrium constant or not? Yes, it will be dependent on the equilibrium constant, because as the concentration increases, the rate constant also increases. It will be directly dependent. So the value of rate constant of water is temperature dependent, as it is an equilibrium constant. The density of the pure water is 1000 gram per liter and the molar mass is 18 gram per mole. From the molarity of pure water, it can be given. If you want to calculate the molarity, it's very easy, you know very well. For molarity is equal to H2O, molarity of water is equal to 1000 upon 18. If you will divide this 1000 upon 18, can you divide this 1000 upon 18? It's very easy. It will be 55.55. What is the value? 55.55. Why? 18 5s are 90, 18 5s are 90.55. That's why 55.55 molarities. So as you get the value of this ratio, the dissociated water to that the undissociated water, then you can say that 10 to the power minus 7 upon this value. What will be the value? As you can see here, the value is 10 to the power minus 7 and the value which you have got it, that is 55.55. Then if you calculate this value, which will be equal to, when you divide this 10 to the power minus 7 by 55.55, then 1.8 into 10 to the power minus 9. 1.8 into 10 to the power minus 9, or approximately 2 into 10 to the power minus 9. So here, after getting this value, this is the equilibrium lies mainly towards the undissociated water. So if anyone will ask you that Acidic acid means hydronium ion is greater than hydroxyl ion. In acidic, in neutral, hydronium ion is equal to hydroxide ion, and in basic, hydroxide ion is greater than hydronium ion. So this was the ionization constant of water and its ionic product. Now the main thing which we are going to discuss is pH scale. Hydronium ion concentration in molarity is more conveniently expressed through a logarithm scale known as pH scale. The pH of a solution is defined as the negative logarithm to base 10 to the activity H plus of hydrogen ion, and the dilute solution is less than 0.01 molarity. The hydrogen ion is equal to the magnitude of molarity represented by hydrogen ion concentration. It should be noted that the activity has no units and defined as H plus by mole per liter. From the definition of pH of the following should be written like that. What? See, first of all, these all the things are related from the 10th standard only. If you have deeply studied 10th standard in second chapter acid base theory, then I hope there is no little bit also difference. You must have constant, or you can say that confident knowledge about that acid base theory. See, in each and every standard we just upgrade. I hope that from 7th standard this acid base salt chapter comes. From 7 it converts into the 8, and then it comes into the 10th standard. And from 10 now in the 11th standard, this acid base theory has been converted into the ionic equilibrium. As you know, ionic equilibrium, that time in the 10th standard also you may have calculated pH value. So first of all, let's write this pH value. Now the pH scale. Now if I talk about this pH scale, if anybody will ask you what is this pH scale, sir, can you tell me? If anybody will ask us what is pH scale, it is nothing. Hydronium ion concentration is expressed on a logarithm scale is known as pH scale. Means you can say you have studied in the 10th standard, yeah, that neutral water is neutral and its pH scale value is 7. Less than 7 is acidic, and greater than 7 and less than 14 is basic, and equal to 7 is neutral, right? These are all the things we have already studied in the 10th standard. But if I talk about the concentrations, molarity and everything, because here it's not only enough to understand what is the acidic pH value, what is the basic pH value, whatever the things we have studied in the 10th standard, the same things we are going to represent also, that how we should know that. You can say that if we were dividing the pH values, how we were calculating the numericals of that water's pH and any other substances pH value. So first of all, I would like to say you that the pH of a solution is defined as in the negative logarithm to the base 10. So here AH plus, here you can see here, that's why I have written here pH is equal to minus log A. This is represented into the negative logarithm AH plus, right? So here that is a concentration of hydrogen ion in the dilute solution which is less than, or you can say which is less than 0.01 molarity, right? So here the hydrogen ion is equal to the magnitude of molarity which is represented by H plus. Okay. Now I will directly come that pH is equal to minus log AH plus. So what will be the value of log? So the log value will be, pH value will be minus log H plus concentration. minus log H plus concentrations upon mole. Now you can say, sir, how this H plus has came? Directly, if you know very well that mole per liter. Here, if you know the logarithm, how to calculate the log values, then the pH value of here, the pH is equal to minus log AH plus, and it has become minus log H plus upon mole per liter. Now for the acidic solution, basic solution, or for the neutral solution, now if anybody will ask you, sir, if you put here, just suppose, sir, if you are putting here pH is equal to minus log 10 to the power minus 7. What will be the value of this? Just I am asking you, okay? So here the pH is equal to, this minus 7 will come ahead, minus into minus 7 log 10. And log 10 value is 1, you know very well. So here the value will be 7. So the pH value of water is 7. Okay? So by this way, I hope that these all the things you know very well. So acidic solution, basic solution, and neutral solution. Do you know the values of pH? I hope you know. Acidic solution pH value. Acidic solution pH value. Can you tell me it is less than 7 or greater than 7? It is less than 7. Right? Basic solution is, basic solution pH value is greater than 7, and neutral solution pH value is equal to 7, right? These things you know, I think so, when in 7th standard also you know, these are all the things we have studied. Now we have to consider the rate constant of water. Have you remembered the rate constant of water? What was the rate constant of water? Kw is equal to, Kw is equal to, I hope you have remembered, Kw is equal to H3O plus and OH minus ion concentration. Right? Here rate constant of water. Now we are taking both the sides log. It means in left side also and right side, in the Kw side also and in water, that H3O plus and OH minus side. First of all, you should know, since it is both the sides, there will be a negative now. So if we take, then it will become minus log Kw is equal to minus log H3O plus into OH minus. Right? Log A into B. Log A plus log B, you know very well. And log, since it is a minus, that's why what will be here? Minus into log A plus will be minus log A and minus log B. Right? Am I right? Yes or no? Yes. So here, what will be the value? I hope that you know, minus log Kw is equal to, since here A into B and here it is minus, so that's why minus log H3O plus and minus log OH minus. Can you write this? Because you know very well, log A into B is equal to log A plus log B. But here it was minus. So it will become minus. So that's why minus log A minus log B. Right? So this thing you should remember this formula. That's why I have written on the board that you should remember this formula. Now already we have calculated the value of this H3O plus and OH minus. So can you tell me what will be the value here? It will be 10 to the power minus 14. Why it will be 10 to the power minus 14? Can you tell me? Because here minus log 10 to the power minus 14 minus log 10 to the power minus 14. Just so what do you understand about this? So here if I talk about the pH value, similarly constant water pH value will be equal to hydrogen ion concentration, the pH and pOH, right? pH plus pOH, and both the value is 10 to the power minus 14. pH plus pOH is equal to 10 to the power minus 14, that is equal to 10 to the power 14. Means if you calculate this minus log 10 to the power minus 14, that will be equal to 14. So pKW is equal to pH plus pOH, which is equal to 40. Here you have to note that Kw can change with the temperature, with the variance in pH, with the temperature is so small, so we can ignore it. But here, if we talk about the rate constant P, very important quantity for aqueous solution and controls the relative concentrations of hydrogen and hydroxide ion in a constant scale. So pH scale is a logarithmic, and a change in pH by just 1 unit also means a change in hydrogen ion concentration by a factor of 10. Similarly, when the hydrogen ion concentration changes by a factor of 100, the value of pH changes by 2 units. Now you can realize why the change of pH with the temperature is often ignored. Now the measurement of pH of a solution is very essential, and its value should be known when dealing with the biological and cosmetic applications. See, nowadays you know very well, it's very important to understand whatever you are buying. If you are doing anything, just like this, suppose you are using any cream, Fair and Lovely, so what is your skin pH value, and by what concentration that cream is being prepared. If the concentration of the skin will mismatch, then definitely you will get some allergic and some small wounds you will get on your face. So why I am telling you this, all the pH value, you should remember the concentration. Each and everything concentrations is very much important. If some person you will see that they are having very much allergy with the different things, as they are putting the perfumes or body spray on their body, then also they get red pimples on their body. Why? The pH value of that perfume and the pH value of that person's skin does not match. It cannot sustain those concentrated perfumes on that skin, so that's why they get a pimple. Yeah, many of the beauty parlors, when you go to the salon, in that salon when we do shaving, they put different acidic solution that it gives a good fragrance. But some persons do not like to put those fragrance items because their skin pH value is very low and it's in acidic medium. So when they put a lot of more acidic concentration on that skin, then they suddenly get pimples on the face. So that's why maximum people do not. And I request also many of the persons do not use much more acidic items. Some person divide this perfume into strong perfume and it is a well-suited perfume. Strong perfume means what? It is having a high concentration. As it have a high concentration and your body do not have sustaining power of those pH, then definitely your body will be harmed by it. So that's why nowadays people are not putting on the skin, they are putting on their clothes. That if that is harmful also, the clothes will be harmed. Right? So I hope that all of you understand about the hydrogen ion or hydronium ion concentration, which is expressed in a logarithm scale, which is also called pH scale. As you have seen, pH is equal to minus log AH plus minus log AH plus mole. Acidic solution, basic solution, these are all the things. Now we will solve one numerical. Now here, one numerical we are going to solve. So the question is, the concentration of hydrogen ion in a sample of soft drink. Sample of soft drink is 3.8 into 10 to the power minus 3 molarity. What is its pH value? Okay, no problem. Here the sample of a pH drink, pH is equal to minus log, what is the value? The value is 3.8 into 10 to the power minus 3. 3.8 into 10 to the power minus 3. So what will be the pH value? pH is equal to minus log 3.8 minus log 10 to the power minus 3. Right? So here minus log 3.8 minus 3 log 10. What is the value of log base 10? I hope everybody know. So it is 3 only, and here log 3.8 value is 0.58. 0.58. So minus 0.58 minus 3. Right? So it will be minus 3.58. So what is the value of pH? It is minus 3.58. Is it minus 3.58 or it will be less? I hope it will be less. What we have to do here, minus minus, it will be plus. Here it will be plus, minus minus plus, 3 log 10 plus 3 here. So here 3 minus 0.58. You have to do minus 3 minus 0.58. Sorry, 3 minus 0.58, what will be the value? 3 minus 0.58. So 10 minus 8, 2, 9 minus 5, 4 and 2.42. The value of this soft drink is 2.42. So therefore the pH of the soft drink is 2.42. It can be inferred that it is acidic. You know very well, when it will be less than 7, that is acidic. If it will be more than 7, that will be basic, but less than 40. Here the value is 2.42, so it is preferred that it is an acidic solution. Next question is, calculate the pH of 1 into 10 to the power minus 8 and solution of HCl. Right? Here, is it HCl or anything else? Let me see, just check. No, it is HCl only. Here, yeah. Same process, nothing else. The pH value is given. What do you have to calculate? pH. So in the same process, you can calculate the pH of this 1.0 into 10 to the power minus 8. Just remember the log values, nothing else. If you know the log value, then it's very easy. Yeah, how to see the log value, that is a little bit difficult, but it is, I hope that your physics taught you that how to see that in log table. If you know how to use the log table, then it's very easy. Just you should know the multiply of expressions. Just remember that log A minus B is equal to log A upon log B, or here you can say log A into B is equal to log A plus log B. Remember these things, okay? These expressions, formulas, nothing else. Try to solve more and more numerical based upon this pH values, and if you don't have, then you can download the numericals based on hard acid, soft base. And in the next video we will discuss specially about the dissociation of ionization constant, means ionization constant of weak acid, weak base, strong acid, strong base, and the ionization of weak base especially. And then we will establish a relation between Ka, means constant of acid and constant of base. That will be much more important for us, because those things are important when we go through that, when we get the values of the rate constant of strong acid and strong base. So learn little by little, as again the government has banned for the school opening. That is a very really disappointing thing, that which we were expecting that after Diwali that there will be a much more interactive classes by the student and teachers, but these things happen a little bit more away. Let's see when it's going to open. No, but no need to worry. Whenever you feel difficulties, when you do not understand any concept, then you are free to call me. Already each and everyone have my number, so you can call me anytime. You can ask me your doubts. That's all for today. Hope all of you understand. Thank you very much. If you don't like and subscribe my channel, then don't forget to like and subscribe my channel. That's all for today. Thank you very much.